Hello, beautiful people, and today we're going to be doing Leetcode 704 binary search. Like, the reason I'm making this video is to kind of just like do a visualization as to what happens at each step of the code, because I feel like it really helps me to be able to visualize what happens, and that way you kind of understand why each line of the code is what it is and what each line of the code is doing and updating to while we go through the solution. So maybe take a pause here, have a look at the solution if you haven't seen it before, just so that when we're going to go through it, you're really understanding like what's going on. Because okay, cool. I'm assuming you paused here. Anyway, let's keep going. So here we have a number array. So we have an array of 6 numbers here. We want to find the target 9. And we can see that the index of 4 is where target 9 is. So we should be outputted 4, right? So that's because 0, 1, 2, 3, 4 is 9 over here, right? So going into the solution, we need to have several pointers in order for our binary search algorithm to work, because the way that binary search works is that it'll check through the array while the left point is less than the right pointer. It'll get a mid pointer, and then it will check if the target is the same as that mid pointer. If it is, it returns it. If not, it checks if the target to the midpoint, if the target is more than the midpoint, then we want to remove half the array. Same as if the target is less than the midpoint, then we want to remove the other half of the array. So to put that a bit more simply, let's go through it step by step. So we have L equals 0 and R equals 5, because it will equal length of nums minus 1. The reason why we're doing length of num minus 1 is because length of nums is 6, right? So if we were to check nums 6, we would get an index out of bounds, right? Because we'd go 0, 1, 2, 3, 4, 5. There's no 6, they're out of bounds. So that's why we do length of nums minus 1. So now we go mid, right? We want to get our midpoint. So we want to get the point right in the middle, right? So where is that going to end up? It's going to be our left pointer plus our right pointer divided by 2. Why is it left plus right divided by 2? Why is it not like length of nums divided by 2? Because that would also be a midpoint, right? No, because we want to be able to update our left, well, yes, but anyway, the reason is because we want to update our left pointer and our right pointer while we go through the while loop. So our midpointer will update each time we go through, and you'll see that as we go. So our midpoint is L plus R minus 2, which is 2. We see right here. The reason why it's 2 is because L plus 5, L is 0, R is 5, 0 plus 5, 5. Who'd have thunk it? Divided by 2 is 2.5. 2.5, anytime any type of division is happening in Python, it rounds down. So it rounds down to 2. So yeah, it rounds down. 2.5 rounds down to 2. So that means that we'd get our second index, which is 0, 1, 2. So great. We have our midpoint, we have our left pointer, and we have our right pointer. Now the first part of our loop is going to check if our target is equal to nums mid. So we're going to check the index that's at mid, which is 2. We're going to check if that number right there is equal to our target. That number is 3. It's not equal to our target, so we get to the next point of the loop. Next part of the loop is checking if our target is more than nums mid. So is target more than nums mid? Yes, because 9 is more than 3. And if that happens, what do we want to check? It means that we only need to check this part of the array now. There's no point in checking this part of the array because we know that this is an ascending order. And because we know it's an ascending order, and we know that 9 is more than 3, there's no point in checking any of these numbers anymore, right? We only want to check these ones. So that means we want to update our left pointer to mid plus 1. So now we see our mid pointer is updated, and now it's updated to 9. And now when we go through, we check if target is equal to nums mid, it'll say yes. And you'd be like, huzzah, it is equal to nums mid. Woohoo. So yeah, that's how that works with binary search. We can also see how it works if we had a target that was on the other side and it was R. So let's say that we do another trace through here. We have our target is 0 now, so we'll be on this side of the array. So now we want to only get the left side of the binary tree. Not the binary tree, the left side of the array for binary search. So same here. Left pointer is 0. Right pointer is still length of nums. Mid pointer will still be 2. So it'll still be 3. But now, instead of target being more than nums mid, it's now less than nums mid. So it will go into our else function. So we know it's not target. We know it's not this one. Now it's else. So now our right pointer right here is going to move to mid minus 1, right? So now we can see mid minus 1, left pointer is 0, right pointer is 1. That will round down to 0. It's going to check if that's equal to 0. It's not. So it's going to check if target is more than nums mid. Right now, nums mid is minus 1. It is, in fact, more than nums mid. So it's going to do the mid plus 1. And then now it's doing mid plus 1. We're at our number. So it's going to check if target is equal to nums mid. And since it is, we're returning mid. So yeah, that's how that works. I think there's also a way to do it where you do r equals just mid. But I think that has some error and edge cases that it doesn't work out for. So for safety's sake, I always do mid minus 1. I know that's also some talk of like how this can sometimes overflow with large numbers, but that really shouldn't be an issue with Python. So this should be, if you're doing your test in Python, this should be fine. But yeah, hopefully that was helpful. Yeah. Oh, make sure you remember your return statement. If none of these check out and it never is able to find a number, you make sure you return minus 1. All right. Hope that helped.